All right, welcome back, everyone. Last time, we laid down the essential foundation of neural networks, but today we're building the skyscrapers. We're going to dive into the powerful, absolutely fascinating variations that have fueled the biggest breakthroughs we're seeing in AI, from how machines learn to see to how they create and even how they write. So that's really the big question we're tackling today. And I know, it might sound a little bit like science fiction, but it's the reality we're all living in right now. And the answers aren't magic. They lie in three really clever innovations in how we design neural networks, and we're about to break them all down. So here's what we've got on deck. We'll start with why we even needed to go beyond the basics in the first place. Then we'll get into the specifics, how machines see using CNNs, how they create new things with GANs, and of course, how they write with LLMs. And finally, we'll take a quick look at what's just over the horizon. Okay, so first things first, why couldn't we just, take the simple networks we already learned about and just make them bigger and bigger? Well, it turns out just scaling things up creates a massive fundamental problem. And this is the heart of the problem. Think about it. Say you're trying to teach a network to spot a cat in a photo. If you have to train a different weight for every single pixel in every possible spot, well, the number of connections just explodes into the billions. You literally need more cat pictures than exist on the entire internet to train it properly. It's not realistic. We needed a smarter, more elegant solution. And that first really elegant solution, it came from the world of computer vision. It's called a convolutional neural network, or CNN for short. And let me tell you, these things totally changed the game for how machines process images. I mean, think about it from our perspective, right? You see a stop sign, and it doesn't matter if it's way over in the corner of your eye or right up in your face, it's a stop sign. But for a basic neural network, nuh-uh. You move that sign just a few pixels to the left and to the network, that's a whole new picture. It has to learn it all over again. CNNs were built to fix exactly that. And this is the genius of it. See, instead of trying to memorize the whole image in one go, CNNs learn to spot little, reusable features, like a sharp edge here or a gentle curve there. And here's the kicker. The network learns to find that specific feature anywhere in the picture. That's how it solves our stop sign problem. It's not looking for the whole sign in one spot. It's looking for the pieces. So how does it do it? The really clever trick is this idea of sharing weights. Instead of having a separate detective for every single pixel in the photo, which is insane, you have a small team of specialized detectors. Think of them like a little search party. Maybe one is an expert at finding pointy ears. Another one is a pro at spotting whiskers. They just scan across the whole image looking for their one thing. Then the network puts it all together and says, hey, I found pointy ears, whiskers, and a nose. Pretty sure that's a cat. It's just a way more efficient way to see. Okay, so CNNs gave machines eyes. They can see what's already there. But what about imagination? What about creating something completely new from scratch? Well, that brings us to our next big breakthrough, generative adversarial networks, GANs. The idea behind a GAN is so cool. It's basically a competition, a duel between two neural networks. You've got the generator, think of it like a master art forger, doing its best to paint a convincing fake. And on the other side, you've got the adversary. That's the sharp-eyed art critic, trying to spot the forgery. And at first, they're both pretty bad at their jobs. But they push each other, they get better, and they learn incredibly fast. And this right here, this is the whole point of the process. The generator gets so good at making fakes, and the adversary gets so good at spotting them, that the generator is forced to create images that are just incredibly realistic. The forger gets so good that it has to create masterpieces just to have a chance of fooling the critic. Eventually, the fakes become so good, they're basically indistinguishable from the real thing. And listen, this isn't just some lab experiment. This tech is out there in the wild right now, generating faces you've probably seen on social media profiles that look completely real. It really makes you stop and think, right? About art, about media, about what's even real anymore. All right, so we've covered seeing and creating. Now for the third piece of the puzzle, writing. And this is the one you've definitely heard about. We're talking about large language models, or LLMs, powered by an incredible architecture called the transformer. So before the transformer came along, language models had a big problem. They really struggled with long sentences. The huge breakthrough, which came from a paper famously titled Attention is All You Need, was something called the attention mechanism. It's a way for the model to, pay attention to the most important words in a sentence when it's figuring out what to say next. So if you ask, what is the capital of France? It knows, okay, I gotta focus on capital and France. It sounds simple, but it was a total game changer. And once that key was turned, the floodgates just opened. The pace of development has been, well, honestly, it's been kind of insane. You go from the first big models like BERT and GPT-1 in 2018, and then just 4 years later, ChatGPT hits the public and changes everything. And then boom, even more powerful models right after that. The pace has been absolutely breathtaking. Now, it's really easy to think of these things as magic, but at their heart, here's what they do. They are incredibly powerful predictive text machines. It's like the autocomplete on your phone, but on steroids. If you give it a phrase like, the capital of Finland is, it has read so much of the internet that it can calculate with very high probability that the next word should be Helsinki. But here's the crazy part. When you do that simple thing, predicting the next word, over and over again at a truly massive scale, amazing, almost magical abilities start to emerge. Things like reasoning and creativity and conversation. And the impact on the world? It was an earthquake. Seriously, nothing in the history of technology has ever grown this quickly. 100 million users in just 2 months? That's not just a successful product launch. That was a global cultural event. It put the power of this kind of AI into the hands of regular people for the very first time. So, let's take a breath. Machines can see, they can create, and they can write. Let's try and tie all these threads together and look at the big question that's left on the table. So these are the 3 pillars we've covered, right? You have CNNs, which master vision by looking for small, reusable features. Then you have GANs, which create brand new things through this clever competition. And finally, LLMs, which master language using that attention idea and just a staggering amount of data. Each one is a brilliant solution to a really, really hard problem. And that brings us to the big, critical question we want to leave you with. These models are masters of language. They can write a poem, an email, a piece of code. They've got the style and the structure down perfectly. But they learned from the internet, which is, a messy place. So the question is, how do we take this amazing ability to generate language and connect it to things that are reliably, factually true? That's the next great challenge. And it's a puzzle that we are all, right now, trying to solve. Thanks for joining me.